Okay, so for this video, we're going to talk about sample-based sound generation. So just to kind of give you an intro to that, in the last video, Aaron was talking about these early synthesizers and how what they would do is they would try to recreate sounds of like flutes, guitars, pianos, and they would sound sort of like those sounds that they're trying to emulate, but they wouldn't really sound like the true thing. So in comes the sample-based synthesizer. So take it away, Aaron.
uh, yeah, backing up, repeat everything you just said. We have sample-based synths. Well, here. So when you want to do things like this, right? When you want it to really sound like a piano, you can do that in one of two ways. Either you can start with sine waves, which is the last video, right? And we can say, okay, we're going to build up sine waves and we're going to try to make it sound like a piano. And you can get limited success like that. But at the end of the day, what you get is like a synth that sounds kind of like a piano. So somewhere along the way, once computer power got a lot better, people started saying, okay, well, throw that out the window. What if I just record a piano? I record it at every key and I record it with like hitting the key soft as well as hitting the key hard. And then we figure out like, how do we mix these things all together, right? So on one level, this type of synth is much, much simpler than a generative, than one that starts with sine waves and stuff, because you don't have to invent the sound. You've already got the sound. On another level, though, it's way harder because you now have to deal with all of these. First of all, a lot of them don't sample every single key. And even if they did, what if you pitch bend in between keys, right? So most of the time you're going to have to deal with resampling these samples, and you're going to have to do that really intelligently and possibly like in the middle of an audio buffer if you're trying to support a user that's doing like real-time pitch bend and that kind of thing. And so dealing with sample playing, like not aliased, getting real smart about how we sample it. But then also there's a lot of complexity because like we just said, like if you hit it soft, there's a different thing that happens than when you hit it hard, right? And this is also the case with real instruments. So you're going to be judged by a different standard. When you're suddenly trying to make it sound like a piano, if you really want it to sound like a piano, people are going to want all those little intricacies. So you're going to have to do things like make it, the harder you hit the key, that the attack speed changes a little bit or things like that.
Yeah. Yeah. So sometimes, especially on really high-end sample-based instruments, you can have something where you have 12 different velocities for up to 12 different velocities for one single key. So that means that depending on how hard or how soft you actually hit that key, it would trigger one of 12 sounds that are just for that one key. So yeah, some of the sample libraries for these get quite big.
Well, and then, yeah, you start to get a trade-off, less so today because computers are so powerful, but there is a trade-off between like how much content do we actually have versus how much do we need to manipulate that content. Right?
Yeah. And there are actually kind of crossovers between these two subjects that we've discussed so far, where you have oscillators and then you have sample-based instruments. You could have sample-based instruments that are basically playing an oscillator, but just one cycle of an oscillator. They call it a wavetable synth. So you have one cycle of a wave that is a wave file, and then what you're doing is you're taking that wave file and then you're playing it back at different speeds, and so it's kind of both. It's a sample-based instrument, but it's actually
wavetable synth is like made to be like an old school synth, but at some point people realized it was going to be easier than generating the sine waves on the fly. It was going to be easier to have one that was recorded, cached in memory, as it were, and then just manipulate that. So and both of those approaches are still completely valid today. I mean, you can start out and decide that you want to generate it as it goes, which affords you a lot of flexibility. Mm-hmm. So you can do a lot of crazy things where you can like reset it right in the middle if you're smart about how you do it. Mm-hmm. But it's also sometimes easier, sometimes faster, and often sounds just as good or even better. Just to have a wavetable, as you said, like, so you have a bunch of samples and you kind of control how they work together. So a wavetable synth is kind of like a very simple, fully sampled synth.
Yeah. Great. Is there anything else that we need to cover with sound generated?
Yeah, well, there's a couple little odds and ends we didn't touch on, right? Like, well, this is kind of in mixing too. But two things that we didn't really talk about was physical modeling synths and mono versus polyphonic synths, which touches on mastering too. But we could talk about those two things quickly if you want.
Yeah, so physical modeling synth is something that's really interesting because what that does is you think about the behavior, like let's say that we're trying to physically model, let's say a flute, then what you do is you have really clever people, that are a lot smarter than myself, that basically do really amazing mathematics that can describe the behavior. Like if you have a physical flute, the flute has a certain length, it has like a certain kind of circumference to it. And what these mathematicians can do, I call them wizards, is they can actually use mathematics to describe the behavior of what happens when you blow into a flute, like, and how the circumference of that and how the length of it actually behaves, and then mimic that within a piece of software, which is pretty amazing, isn't it?
Yeah, when you hear physical modeling, just think like heavy math.
Yeah.
It's a lot like our last video, we were talking about generative, we generate sine waves, we decide how to add them up, we do all this other stuff. Physical modeling like takes that and puts it on steroids, because you do all of that kind of generation, but then you say, okay, but what if it's in a room with this sort of dimension and you're standing on a metal plate and the metal plate's moving a little bit, and what if the edge of this instrument is made out of tin instead of made out of whatever, and they just take and like keep adding factors until it starts to approach like the hardcore physics of wave generation. So I mean, if that's your bag, go for it. I don't think we're going to get into a serious video about that because it gets real deep real quick.
Yeah, absolutely. And is there anything else here that we need to go through?
Yeah, I mean, one other thing just to think about, right? So we've shown them these two types of synths, and obviously, if you're the kind of like new to programming, but you really want to make a synth, you should know there's a lot going on there. There's a lot that you got to do, and you should really think about: do you want it to be generative, like create the waveforms, create the sine waves, or do you want it to use samples, or do you want it to be somewhere in between? Like there's the wavetables. There's also hybrid synths, for that matter, that do both. That take a sample, but then they overlay sine waves on top of it, which you can get some really interesting results that way too. So thinking about what you want to generate is step one. And yeah, sky's the limit. Sky's the limit.
Great. Okay, so for this next video, we're going to talk a little bit about controlling the sound. So you have a sound that's being generated. Well, now you have to define how the sound is going to be controlled when you press a key, how the sound actually turns on, and then when you release the key, how it turns off. And for that matter, the functionality that there's even control attached to a key in itself. And that's what we call ADSR, and we're going to discuss that in the next tutorial.